Alright, so we are talking about inverses. So an inverse is where you switch the domain and range. Okay, so quite simply, in our terms, we're going to swap x and y. So, for example, from a table, if our x values are here and our f of x, which is our y values, are here, we're literally just going to take them and flip them around. So x becomes 9, 4, 1, 0, 1, 4, 9. And f inverse, that's the key here. This is that notation that you need to know. To the -1, just like when -1 flips things around, it means the inverse is going to be our, what was our domain values. Okay? So if you get a table, you literally just flip them around. So keep in mind, you're switching the domain and the range. That's what you're doing. So tables, pretty simple. Algebraically, we do the exact same thing, really. F of x really just means y, so sometimes it's easier to view it as y. And then if we switch our domain and range, we're just going to swap x and y. So this is going to become x equals 3y minus 4 over 7. And then we solve for y. So if you can tell that you multiply by 7, you can. If you prefer to put this guy over 1 and cross multiply, that might be a little bit easier, just however you view it. So if I'm going to cross multiply here, which will give me 3y minus 4 equals 7x, then I can add my 4 over. 3y equals, and you write this just how you would say it, 7x plus 4, 7x plus 4, and then we divide everything by 3, and instead of y, we say f to the -1 of x. That means f inverse. That's how you read that, is 7x plus 4 over 3. This is your inverse function. Okay? So this guy is f inverse. Finverse. Ooh, we should call it finverse. Alright, so please pause the recording and try these two. I will tell you what you should get, but go ahead and pause it. You didn't pause it, did you? You slackers. Alright, your answer here for this one should be 2 minus 3x over x. I know it's a little goofy, but I hope that you just cross-multiplied and went with it, stuck with it. This is what you should get. You could have written -3x plus 2 on the top instead if you want. And in the second one, you should get the square root of x plus 8 minus 4 all over 2. If these are really confusing you, make sure that you write a question here for me. Let me know that. We will be practicing them in class as well. Okay? So, horizontal line test is for when you are graphing. Okay? And the key here is we did the vertical line test to test if something was a function. So the horizontal line test will tell us if the inverse is a function. Okay? That is the key. So if it passes, so for instance, if I have the graph, just a parabola, this passes my vertical line test. This guy's a function, but if I do a horizontal line test, it hits 2 points. That means that its inverse is not a function. Okay, that's something we'll look at a little bit more as well. The key here is if it passes, that means it is a one-to-one function. Okay? Alright, So let's check these guys out. If you are given something like this, you are welcome to substitute these numbers in for x and get your y's. You're also welcome to put it into your calculator in your y equals, and then look at your table. Okay? If you do that, you would get 6.5, 4, 2.5, 2, 2.5, 4, and 6.5. Remember, parabolas mirror each other here. So, go ahead and pause the video. See if you can make the table for number 2. Go ahead and pause. Alright, so hopefully you just swapped around your x and y values here. So these are all coordinates, and we're going to plot these below. My suggestion to you, to make this easier, and I'll show you, I'll do it with you, is to plot all of these ones first and then connect them, and then plot these ones and connect them, and maybe even possibly use a different color for these, because otherwise it gets really confusing. Alright, so we're going to plot these lovely points. We have 0, 6. You know what, I think I can just do this, and then I can go boop. There we go. We've got 1, 4, 2, and 2.5, 3 with 2, and then we mirror it. 4 goes to 2.5, 5 goes to 4, and 6 goes to 6. Ooh, 6.5. My bad. Just kidding. This one goes here. Alright. And then you're going to just connect them. Just a nice curve. Goes up this way. Mine's not super pretty. I'm sure yours is much more beautiful than Miss Holly's. And then I'm going to grab a different color here. And we're going to plot the next one. So let's look at our S inverse. Our 6.5, so these ones are going here. 6.5, 0 goes here. 4 goes to 1. 2.5 goes to 2. 2 goes to 3. And then we have to go backwards, which is kind of goofy. I know it kind of fights your instincts. 2.5 goes up to 4. 4 again goes to 5, and 6.5 goes up to 6. So hopefully you can see that this is not a function. The blue one is not a function because we have multiple y values for our x values here. Okay, and then go ahead and pop a little curve here. So orange is our original function, and blue is our f inverse of x. Orange is our f of x. Okay? So if you fold the paper somewhere so that the blue lines up perfectly with the orange, what is the equation of the line that will be created? I don't know if I want to tell you. I feel like I should make you figure it out. You have to at least try this. Okay? If you don't try it, I'm not going to give you all your points. Okay? And that would make me sad. So, you need to see if you can figure out, actually take your paper and fold it somewhere so that these guys line up with each other. These points line up with each other. Okay? And what would be the equation of that line? Think y equals mx plus b. What's your y-intercept? What's your slope? See if you can figure it out. Okay? So as long as you try it, you'll get all your points. That would make me happy. And if you try it and get it correct, maybe I'll give you a 6 out of 5 for your homework. Alright?